My name is Mr. Victor Mwachu, and today I'll be taking you on business statistics and further mathematics. So from your school process, you have the course outline and the course content over there. So we are going to start from the basics. So we are going to treat some topics today. Then as we proceed in the next class, we are going to continue with some other topics. So I will just state the topics that we are going to be treating today. So the first topic is going to be counting. Counting has to do with permutation and combination. Counting, it has to do with permutation and combination. I hope you can see my screen over here. It has to do with permutation and combination. Then after counting, we'll now talk about probability. So, but we have to start first with the counting. So let's get started. We'll start with the permutation, which is the first aspect of the counting in the course. First, we find what permutation is. Permutation is a number of ways of arranging n objects r at a time in an orderly manner. Permutation is the number of ways of arranging n objects r at a time in an orderly manner. I'm going to type it out so that you can see it. Permutation is the number of ways of arranging n objects r at a time in an orderly manner. So this n here that you have here is the total number of objects that you can consider in the statistics. And then this r you have here is the number of objects being selected at a given time, that's at a time, in an orderly manner, not in a random manner. So this is it. So permutation is the number of ways of arranging n objects r at a time in an orderly manner. So that is just the simple basic definition of permutation. So we are going to look at, so now we are going to consider the mathematical expression for permutation. So to consider the mathematical expression for permutation is given by that mathematically n, trying to write it very well so I can see it, n permutation r is equal to, this is n, then capital letter P, r is equal to n factorial all over, you open a bracket here, n minus r, you close the bracket, factorial. That is n factorial all over n minus r factorial, where n is the total number of objects. So we are going to consider an example to understand this better. That's a basic example to understand the permutation better. No, minimize this. So this is an example here. It says Bill has 6 textbooks. Bill has 6 textbooks. This is it here. Bill has 6 textbooks, but can fit only 4 of them onto a small shelf. Bill has 6 textbooks, but can fit only 4 of them onto a small shelf. That's it. If the other 2 textbooks has to sit on the desk, in how many ways can Bill arrange the shelf? So the total number of textbooks that Bill is having here is 6. So if the total number of textbooks here, our n is equal to 6. From the question, your n is equal to 6. Then it says, but you can fit only 4 of them onto a small shelf. That is to say, he can only fit 4 out of the 6. So he's going to arrange these 6 textbooks. That n is the total number. Taking 4, that's the arrow. 4 here is the arrow at a time. So take note. So don't get confused, because the question further says that if the other 2 textbooks has to sit on the desk, then in how many ways can we arrange the shelf? So the 4 that we're having there is the R. Our R there is equal to 4. Our R is 4. The R is 4. So it's a very simple expression or example calculation to understand this very well. So don't get confused and choose the 2 books, because these 2 books have to sit on the desk. These 2 books is not being arranged on the shelf. What we are asked is in how many ways can Bill arrange the shelf. So our focus is arranging the shelf, not arranging the books on the desk. So the 4 here is your R. So then how to calculate the number of ways whereby Bill can arrange the shelf? So you're going to have 6 permutation R. Sorry, I'm going to write it again so it's going to be clearer. 6 permutation 4, that's our R is 4, is equal to 6 factorial all over, you open your brackets, that is 6, that's n is equal to 6 minus 4. 6 minus 4 factorial. So then how to further calculate this? If you want to calculate this, so this is equal to, okay, trying to adjust the screen. So which is equal to, this 6 factorial simply means 6 times 5. 6 times 5 times 4 times 3. 6 times 5 times 4 times 3 times 2 times 1. It would be better if I type it using the letter. All right. So it's going to be 6. That is 6 times 5 times 4 times 3 times 2 times 1 all over all this will be divided by we divide all these by 6 minus 4 is equal to 2. So you're going to have 2 factorial, so which is equal to 2 times 1 times, that's just 2 times 1. You're going to have 2 times 1 here, 2 times 1. Because 6 minus 4 is 2. So you're going to have 2 factorial, and 2 factorial simply means 2 times 1. So when you calculate all these together, you're gonna have that. Okay, there's a little error here. This should be 6 times. Take note of this is 6 times 5. There's a times here, and the multiplication sign here is a mistake. 6 times 5 times 4 times 3 times 2 times 1. Perhaps I'm going to write it all over again. But that's still possible to delete it. Now 6 times 4 times 5 times 4 times 3 times 2 times 1. So this is what ought to be here. So that's that. So you're going to erase this. And you bring this one over to this part. All right, so that is just a simple way of solving simple problems with respect to permutation. It's just the number of ways of arranging n objects r at a time in an orderly manner. So it's just as simple as that. So there are other examples to consider, but let us go further as we proceed. A tax auditor has 6 different returns to audit, but we have time to examine only 5 of them tomorrow. A tax auditor has 9 different returns to audit, but will have time to examine only 5 of them tomorrow. In how many ways, in how many different orders can tomorrow's tax be carried out? In how many different orders can tomorrow's tax be carried out? So here also, you have your n to be your 9, then your 5 to be your r, because out of this 9, he have to audit as an auditor. He can only take 5 at a time. So that's r at a time. So here your n is 9, while your r is 5. So it's just how we'll solve the other one. So here your n is equal to 9, while your n is equal to 9, while your r is equal to 5. So you just follow these same simple steps using the mathematical expression. So your n here is 9, while your r is 5. So in solving this, it's going to be n 9 permutation r. That is, here will now become 9, then here will now become 5. So you now put 9 here, then 9 minus 5. So 9 factorial simply means 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Then you now have 9 minus 5, which will give you 4 here. 9 minus 5, which will give you 4 here. And 9 minus 5 is 4 factorial. So you're going to have 4 times 3 times 2 times 1. So that's just how to calculate or solve that simple problem. So now let us go into the other subtopic under counting, which is combination. That is combination. And I'm clean this off. Combination. Combination is a number of ways. Combination is a number of ways of selecting n objects r at a time in a random manner. Combination is a number of ways of selecting n objects r at a time in a random manner. So here your n is still the same. You're still having the same thing as your total number of objects, while your R here is the number of objects selected out of that total number of objects. That's the number selected out of that total number of objects. That's your R. So your combination is simply defined as the number of ways of selecting n objects R at a time in a random manner. Mathematically, combination is given by combination is expressed as n combination R. I'm going to write it here. N combination R. N combination R. This capital letter CR is equal to n factorial all over n minus R factorial. Then you now have R, all this multiplied by R factorial. So factorial is spelled as, maybe for some of us, one is spelled factorial. So mathematically, combination is expressed as n combination R, that's NCR, is equal to n factorial all over open bracket n minus R close bracket factorial multiplied by R factorial. That is the mathematical expression for combination. So that's that. So in your calculator, because some person might find it difficult to compute, to make it easier, to check it on the calculator. If you have this scientific calculator, you can see it there. So here you are having your factorial. This factorial. This is the factorial here. So you're having the factorial here. So if you see something like this on your calculator, that's simply the factorial. If you want to get 9 factorial, 9 factorial. So this is what it will give you. If you, or let's say if you want to get 3 factorial, that's 3 times 2 times 1. You're going to click on it, then 3 factorial. That's the 3 times 2 times 1 is 6. So that is how you get it. Then if some of us, you have the other kind of calculator, the standard calculator, maybe you're gonna have it there, but this one is the scientific calculator, and the combination and the permutation is also seen there if you have some kind of advanced scientific calculator. The symbol there is NCR. If you can locate that on the calculator, you see the symbol NCR. That's the symbol for combination. So sometimes you can even solve this without thinking twice with your calculator. So that's that. So we'll consider example here with respect to the combination. Let's look at some example here with respect to combination. Okay. Here is that a club. A club has 9 members. A club has 9 members. A club has 9 members. In how many ways can a committee of 3 be chosen from the members of this club? A club has 9 members. In how many ways can a committee of 3 be chosen from this club? In how many ways can a committee of 3 be chosen from this club? So mind you, most times to differentiate between permutation and combination, because they are almost similar, because sometimes the questions comes like they are similar. So a way to differentiate this is to know that the word permutation always have the word arrange in it, in the question, arrangement or arrange, or it has the word orderly. Yes. Why in combination, the questions always come with selection as a keyword in it, or select as a keyword in the question, or it comes with random order or random manner. So that's one way to differentiate questions that has to do with permutation and combination. So to solve this simple question, which says that the club has 9 members, in how many ways can a committee of 3 be chosen from the members of this club? We're going to have here n is our 9, because n is total number. N is equal to 9 here. Y r is equal to 3. In how many ways can a committee of 3 be chosen from these members of this club? So that's that. So it's just as simple as that. So to solve this mathematically, it's going to be 9 combination 3 is equal to 9 factorial all over, you open your brackets. I'm going to have 9 minus 3. Mind you, this is 3. I'm only trying to write it well for you, but you can do better than this. Factorial. Then you now have 3 factorial. 3 factorial. So this is equal to, I'm going to extend this a little bit. The same thing as 9 factorial all over. I'm taking my time to do this so that some of us who are writing can have something to write down. So there's no excuse that I did not write anything. You can write now. 9 minus 3 is 6. You're going to have 6 factorial multiplying 3 factorial. Multiplying 3 factorial. All right, so that's that. So it's just the same way you solve the previous problem on permutation. So it's just the same way you're going to solve this. So you're going to have 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Hello? Hello? Okay, all right. Okay, so you're going to have 9 factorial over this. So that is as simple as that. Then you get the solution to that. So with respect to this, I'm just going to give you just some few assignments over here. So you consider this exercise. You can screenshot it, snap it, or however you want to copy it, can copy it. So you're going to take the first one, exercise 11.2, question 1. Evaluate 8 permutation 3. This is 8 permutation 3. You calculate that. Question 1, question 7, question 10. Question 1, question 7, question 10, and question 18. Question 1, question 7, question 10, and 18. So the question 18 is this. Question 1, 7, 10, and 18. So this is the assignment that you are going to do. Okay, let me see if I can put it up here. It's not going well. So if you have any question, it is a way you can communicate with me. You can communicate with me via mail. You can send it via mail. My email address is you can send it to ikmc.info@gmail.com. That's the email address you're going to send your assignment to. ikmc.info@gmail.com. So you solve it, you can solve it, you snap it, and you send it. If you have any question, you can ask still on this email address. Then if you have you are